All right, in this short video, we're going to be talking about confidence intervals, which isn't really anything new. It's not a new concept. It really just deals with the normal distribution, z-scores, all those things that we've been working on so far. So, quick recap. Normal distribution is a probability distribution. It shows the probabilities of certain values given an average and standard deviations and this normal shape of distributions. Z-scores are just the number of standard deviations you are from the mean. That's all a z-score represents, the number of standard deviations you are from the mean in that normal distribution. And the z-table assigns probabilities, assigns cumulative probabilities to each of those z-scores. Knowing all that lets us build confidence intervals around certain results. So, to define a confidence interval, as usual, I'd like to give you an example. Suppose that you run a restaurant, and on a nightly basis, on an average Saturday night, any Saturday night, you average 100 customers. And you have a standard deviation of 20. Now, we know that 95, or hopefully you all know, that one of the easiest conversions in the z-table, one of the most commonly used, is to say 95% of all results are going to fall within 2 standard deviations of the mean, right? So with this mean and with this standard deviation, we can say, all right, that means that 2 standard deviations to the left is 60 and 2 standard deviations to the right is 140. So 95% of all results are going to fall between 60 and 140, meaning we can say with 95% confidence, say our 95% confidence interval in terms of the number of guests we will have at our restaurant on a Saturday night is 60 to 140. So this is the form of a confidence interval. A confidence interval has a certain percentage associated with it, and the higher the value, the more confident you are. So 95% is pretty confident. And then it takes the form of a range of values. So it has a certain percentage associated with it, your level of confidence, and then a range of values. Let's say, for instance, now so this says with our 95% confidence interval in terms of the number of guests we're going to have on any given night is 60 to 140. Let's say instead, though, that we only wanted to be 90% sure of the number of guests we're going to have in any given Saturday night. So we only care to be 90% confident. What is our range going to be in that case? Well, we're just going to use our same old equation. Probability converts to z, which is going to be equal to x minus the average over the standard deviation. So now, the trick is a confidence interval has a range. It's going to look like this. It's going to look like this. And our confidence is going to be made up of this area in here. So for our previous example, we used 60 and 140, and all of this area in the middle was 95%. That meant that out here, this is the part where we're not as confident. This is 1 minus our confidence, is actually going to be that value. We call this the alpha, the chance that we're not right. Call that alpha, and it's represented by that. This is actually going to be alpha divided by 2. This is, I realize, sort of a complicated explanation for something that's actually pretty straightforward, which is just to say, look, if this is 95%, that means that these two together are going to be equal to 5%, and 5% divided by 2, since we have the right side and we have the left side, is going to be 2.5%. I want you to do this intuitively. In case you're seeing in your textbook, you're seeing alpha and alpha divided by 2. This is where this all originates from. But the main point here is that here's a real easy way to think about this, or at least more straightforward. It's going to be 1 minus confidence divided by 2, right? Everything outside of 95%, that's 1 minus 95%, that's equal to 5% divided by 2. Over here, This is 2.5%. This is 2.5%. Because the normal distribution is symmetrical. So, all that long explanation, that huge digression aside, if we only cared to be if we only needed a 90% confidence interval, then out here and out here is going to be equal to 5% and 5%. And so we can look up, separate these two examples out. We can look that up on our z-table. In fact, it's usually easiest to look up the lower bound, since this is just going to give us exactly 5%. So let's go find 5% in our z-table. It's going to be 0.05. All right, it falls pretty exactly in between negative 1.64 and negative 1.65. So we're going to call this negative 1.645. So that's our lower bound z value, negative 1.645. Is our upper bound z value, positive 1.645. So let's convert that now into an actual into an actual value, a number of customers. Sorry. So if we say 1.645 equals x, the number of customers we're looking for at the upper bound, minus 100, it's our average number of customers on a Saturday night, and our standard deviation of 20, we can solve for this. And what we get is x is going to be equal to 132.9. That's our upper bound. So in our 90% confidence interval, 132.9 guests is going to be the upper bound of our limit, our interval. So let's take a look and figure out what our lower bound is going to be. Well, to figure out the lower bound, we're just going to sub in 1.645, sub in negative 1.645 instead of 1.645. And in fact, what we're going to get is the same distance from the mean, only to the left. And since we were 32.9 guests above the mean on our upper bound, we're going to have the same number of guests below the mean on our lower bound, and that's going to be equal to 67.1 guests. So at a 90% confidence interval, we can be 90% sure we'll get between 61 and 67.1 and 132.9 guests showing up on a Saturday night. Notice something. When we're less confident, when our confidence interval, when we have a 90% confidence instead of 95% confidence, our range narrows somewhat. And this is always the case. The more confident you want to be, the wider your range is going to be. It makes intuitive sense. Let's think about this. You could never, in most situations, theoretically, you can never be 100% confident. Can I say with 100% confidence that I won't have 1 million guests show up to my restaurant on a Saturday night? Not really. I mean, okay, maybe that's an extreme example. You can't have more than the population of the Earth show up, presumably. In other words, you can never really be 100% confident. And the closer you get to 100% confidence, the wider your range is going to be. Obviously, you can have negative guests show up, but your range is going to be really, really big if you're getting very close to 100% confidence. If you I need to be 99.9% confident, well, that's going to be a really big range. On the other hand, if you say, I only want to be right 20% of the time, well, it's going to be you can predict a very narrow range if you only want to be right 20% of the time. So that's the way it goes. The more confidence, the bigger the range. Thus, when we went from 95% confidence down to 90% confidence, our range narrowed somewhat. All right, another example. And I'm going to open up a fresh sheet. Let's say that you grow apples. You own an apple orchard. And the average size of the apples you grow is 115 ounces. Grams. 115 grams. That's your average size of the apples, and the standard deviation is 10 grams. And you sell all of your apples to one grocer. And she is somewhat particular. She doesn't want her apples to be too large, and she doesn't want them to be too small. So that you know she's going to reject the biggest 10% of the apples you give her and the smallest 10% of the apples you give her. This is sort of a silly example, but we're going with it. So she's going to reject the biggest 10% and the smallest 10%, and you want to know what the range is of apples she's going to accept. You want to know, okay, what, in terms of grams, what are the apples she's going to go with? So let's work this out. We know she's rejecting 10% of the 10% biggest and the 10% smallest. So we can convert that. We don't know what x is here, but we can figure out a z-score. And let's go ahead and look at the z-score that's going to give us the cutoff at the bottom 10%. So we're going to go find 10% in our table. I think we've already done this, but I've already forgotten what it is. Yeah, it's negative 1.28. So the lower bound is going to be negative 1.28, and the upper bound is going to be 1.28. And because I said this is a good idea, I'm going to draw out the curve, just so we're all clear. This is 10%. This is 10%. Now, what kind of confidence interval is this going to give us? Let's just say I'm going to pick one apple from my orchard. I want to know, what kind of confidence interval is this going to give me in terms of the size of the apple? Well, if we're based on, I want to know what's the chance it's going to fall within the range specified by the grocer. It's 80%. That's everything in between here. This is 80%. So let's convert these values into actual numbers. These are my z values. So we'll just go with the upper range. To begin with, it doesn't really matter where we start. 1.28 equals x minus 115 over 10. And that's going to give me, I'm going to be lazy and I already did this calculation. That's going to give me 127.8. That's my upper bound. And if we do the same thing on the lower side, you could just subtract 127.8, subtract 115 from 127.8 to give you the range, but I'm just going to go ahead and solve this. The lower bound is going to be 102.2. So this is the range of apples she's going to accept. Between 102.2 and 127.8 grams. And if I pick a random apple from my tree, my confidence interval that it's going to meet the grocer's specification is 80%. I can be 80% sure it's going to fall between 102.2 and 127.8. Now, we're going to see some very practical applications of confidence intervals in the future, not having to do with apples and grocers. But we're really going to use confidence intervals a whole lot when we get to sampling.